Hi.
Good morning. Welcome to day 3 of Google I/O and what should be a fun conversation about machine learning and artificial intelligence. My name is Tom Simonite. I'm San Francisco Bureau Chief for MIT Technology Review. And like all of you, I've been hearing a lot recently about the growing power of machine learning. We've seen some striking results come out of academic and industrial research labs, and they move very quickly into the hands of developers who have been using them to make new products and services and companies. I'm joined by 3 people this morning who can tell us about how this new technology and the capabilities it brings are coming out into the world. They are Aparna Chennapragada, who is the Director of Product Management and worked on the Google Now mobile assistant, Jeff Dean, who leads the Google Brain research group here in Mountain View, and John Gianandrea, who is Head of Search and Machine Intelligence at Google. Thanks for joining me, all of you.
Thanks.
We're going to talk for about 30 minutes, and then there will be time for questions from the floor. John, why don't we start with you? You could set the scene for us. Artificial intelligence and machine learning are not brand new concepts. They've been around for a long time. But we're suddenly hearing a lot more about them. Large companies and small companies are investing more in this technology, and there's a lot of excitement. You can even get a large number of people to come to a talk about this thing early in the morning. So what's going on? Tell these people why they're here.
What's going on? Yeah, thanks, Tom. I mean, I think in the last few years we've seen extraordinary results in fields that hadn't really moved the needle for many years, like speech recognition and image understanding. The error rates are just falling dramatically, mostly because of advances in deep neural networks, so-called deep learning. I think these techniques are not new. People have been using neural networks for many, many years, but a combination of events over the last few years has made them much more effective and caused us to invest a lot in getting them into the hands of developers. People talk about in terms of AI winters and things like this, right? I think we're kind of in an AI spring right now. We're just seeing remarkable progress across a huge number of fields.
Okay. And how long have you worked in artificial intelligence, John?
Well, we started investing heavily in this at Google about 4 years ago. I mean, we've been working in these fields like speech recognition for over a decade.
Okay.
But we kind of got serious about our investments about 4 years ago and getting organized to do things that ultimately resulted in the release of things like TensorFlow, which Jeff Teams worked on.
Okay, and we'll talk more about that later, I'm sure. Aparna, give us a perspective from the view of someone who builds products. So John says this technology has suddenly become more powerful and accurate and useful. Does that open up new horizons for you when you're thinking about what you can build?
Yeah, absolutely. I think for me, these are great as a technology, but as a means to an end. They're powerful toolkits, but to help solve real problems, right? And for us, as building products, and for you guys too, there's 2 ways that machine learning changes the game. One is that it can turbocharge existing use cases, that is, existing problems like speech recognition, by dramatically changing some technical components that power the product. If you're building a voice-enabled assistant, the word error rate that John was talking about, as soon as it dropped, we actually saw the usage go up, right? So the product gets more usable as machine learning improves the underlying engine, right? Same thing with translation. As translation gets better, Google Translate, it scales to 100+ languages, right? And photos is a great example. You've heard Sundar talk about it too, that as soon as you have better image understanding, the photo labeling gets better, and therefore I can organize my photos. So it's a means to an end. That's one way, certainly, that we have seen. But I think the second way that's personally far more exciting to see is where it can unlock new product use cases, right? So turbocharging existing use cases is one thing, but where can you kind of see problems that really weren't thought of as AI or data problems? And thanks to mobile here, right, 3 billion phones, a lot of the real-world problems are turning into AI problems, right? Transportation, health, and so on. That's pretty exciting, too.
Okay. And so is one consequence of this that we can make computers less annoying, do you think? I mean, that would be nice. I think we've all had this experience where you have a very clear idea of what it is you're trying to do, but it feels like the software is doing everything it can to stop you. Maybe that's a form of artificial intelligence too, I don't know. But I mean, can you make more seamless experiences that just make life easier?
Yeah, and I think in this case, again, like one of the things to think about is how do you make sure, especially as you build products, how do you make sure your interface scales with the intelligence, right? Like the UI needs to be proportional to AI. Like I can't believe I said some pseudo formula in front of Jeff Dean, but I think that's really important to make sure that the UI scales with the AI.
Okay, and Jeff, for people like Aparna and building products to do that, we need this kind of translation step, which your group is working on. So Google Brain is a research group, works on some very fundamental questions in this field, but you also build this infrastructure, which you're kind of inventing from scratch, that makes it possible to use this stuff.
Yeah, I mean, I think, obviously in order to make progress on these kinds of problems, it's really important to be able to try lots of experiments and do that as quickly as you can. There's a very sort of fundamental difference between having an experiment take a few hours versus something that takes 6 weeks. It's just a very different model of doing science. And so one of the things we work on is trying to build really scalable systems that are also flexible and easy to express new kinds of machine learning ideas. And so that's how TensorFlow came about. It's sort of our internal research vehicle, but also sort of robust enough to take something you've done and done lots of experiments on, and then when you get something that works well, to take that and move it into a production environment. Run things on mobile phones or in data centers, on our TPUs that we announced a couple days ago. And that seamless transition from research to putting things into real products is what we're all about.
Okay, and so TensorFlow is this very flexible package. It's very valuable to Google. You're building a lot of things on top of it, but you're giving it away for free. Have you thought this through? Isn't this something you should be keeping closely held?
Yeah, there was actually a little bit of debate internally, but I think we decided to open source it, and it's got a nice Apache 2.0 license, which basically means you can take it and do pretty much whatever you want with it. The reason we did that is several-fold. One is we think it's a really good way of making research ideas in machine learning propagate more quickly throughout the community. People can publish existing, of something they've done, and people can pick up that thing and reproduce those people's results or build on them. And if you look on GitHub, there's like 1,500 repositories now that mention TensorFlow, and only 5 of them are from Google.
Right.
And so it's people doing all kinds of stuff with TensorFlow. And I think that free exchange of ideas and accelerating that is one of the main reasons we did that.
Okay. And where is this going? So I imagine right now that TensorFlow is mostly used by people who are quite familiar with machine learning, but ultimately, the way I hear Google talk about machine learning, it's just going to be used by everyone, everywhere. So can developers who don't have much of a background in this stuff pick it up yet? Is that possible?
Yeah, so I think actually there's a whole set of ways in which people can take advantage of machine learning. One is, as a fundamental machine learning researcher, you want to develop new algorithms, and that's going to be a relatively small fraction of people in the world. But as new algorithms and models are developed to solve particular problems, those models can be applied in lots of different kinds of things. If you look at the use of machine learning in the diabetic retinopathy stuff that Sundar mentioned a couple days ago, that's a very similar problem to a lot of other problems where you're trying to look at an image and detect some part of it that's unusual. Mm-hmm. We have a similar problem of finding text in Street View images so that we can read the text. And that looks pretty similar to a model to detect, diseased parts of an eye. It's just different training data, but the same model. And so I think the broader set of models will be accessible to more and more people. And then there's even an easier way where you don't really need much machine learning knowledge at all, and that is to use pre-trained APIs.
Right.
So essentially, you can use our Cloud Vision API or our speech APIs very simply. You just give us an image, and we give you back good stuff. And as part of the TensorFlow open source, we also released, for example, an inception model that does image classification. That's the same model as underlies Google Photos.
Okay. So it will be possible for someone, maybe they're an experienced builder of apps, but don't know much about machine learning. They could just have an idea and kind of use these building blocks and plug them together.
Yeah. Actually, I think one of the reasons TensorFlow has taken off is the tutorials in TensorFlow are actually quite good at illustrating, 6 or 7 sort of important kinds of models in machine learning and showing people how how they work, stepping through both the machine learning that's going on underneath and also how you express them in TensorFlow. That's been pretty well received.
Okay. And Aparna, I think we've seen in the past that when a new platform of mode of interaction comes forward, we have to experiment with it for some time before we figure out what works, right? So, and sometimes when we look back, we might think, oh, you know, those first generation mobile apps were kind of clunky and maybe not so smart. How are we going with that process here? We're starting to have to understand what types of interaction work.
Yeah, and I think that's, it's one of the things that's not intuitive when you start out, like you rush out into a new area like we've all done. So one experience, for example, when we started working on Google Now, one thing we realized is it's really important to make sure that, depending on the product domain, some of these black box systems, you need to pay attention to what we call internally as the wow to WTH ratio. That is, as soon as you kind of say, hey, there are some delightful, magical moments, right? But then if you kind of get it wrong, there's a high cost to the user. Mm-hmm. So to give you an example, in Google search, let's say you search for, I don't know, Justin Timberlake, and like we got a slightly less relevant answer. Not a big deal, right? But then if the assistant told you to sit in the car, go drive to the airport, and you missed your flight, what the hell, right? So I think it's really important to get that ratio right, especially in the early stages of this new platform. Right. The other thing we noticed also is that explainability or interpretability really builds trust in many of these cases. So you want to be careful about looking at which parts of the problem you use machine learning and you drop this into. You want to look at problems that are easy for machines and hard for humans, right? The repetitive things, and then make sure that those are the problems that you throw machine learning against. But you don't want to be unpredictable and inscrutable. Mm-hmm.
And one mode of interaction that everyone seems to be very excited about now is this idea of conversational interface. So we saw the introduction on Wednesday of Google Assistant, but lots of other companies are building these things too. Do we know that definitely works? Like, what do we know about how you design a conversational interface, or what the limitations and strengths are?
I think, again, at a broad level, you want to make sure that you can have this trust. So narrower domains make it easy. So it's very hard to make a very horizontal system work that works for anything. But I'm actually pretty excited at the progress, right? We just launched open source the sentence parser, Parsi McParseface. I just wanted to say that name. But it's really exciting because then you say, okay, you're starting to see the beginning of conversational, or at least like a natural language sentence understanding, and then you have building blocks that build on top of it.
Okay.
Right?
And John, with your search hat on for a second, so we heard on Wednesday that I think 20% of US searches are now done by voice, so people have clearly got comfortable with this, and you've managed to provide something that they want to use. Is the assistant interface to search going to grow in a similar way, do you think? Is it going to take over a big chunk of people's search queries?
Yeah, I mean, we think of the assistant as a fundamentally different product than search. And I think it's going to be used in a different way. But we've been working on what we call voice search for many, many years. And we have this evidence that people like it and are using it. And I would say our key differentiator there is just the depth of search and the number of questions we can answer and the kinds of complexities that we can deal with. I think language and dialogue is the big unsolved problem in computer science.
Right.
So imagine reading an article and then writing a shorter version of it. That's currently beyond the state of the art. I think the important thing about the open source release we did of the parser is it's using TensorFlow as well. So in the same way as Jeff explained, the functionality that's in Google Photos for finding your photos is actually available open source, and people can actually play with it and run a cloud version of it. We feel the same way about natural language understanding, and we have many more years of investment to make in getting to really natural dialogue systems where you can say anything you want, and we have a good shot at understanding it. So for us, this is a journey. Clearly, we have a fairly usable product in voice search today, and the assistant, we hope, when we launch it later this year, people will similarly like to use it and find it useful.
Okay. Do you need a different monetization model for the assistant dialogue? Is that something?
We're really focused right now on building something that users like to use. I think Google has a long history of trying to build things that people find useful, and if they find them useful and they use them at scale, then we'll figure out a way to actually have a business to support that.
Okay, okay. So you mentioned that there are still a lot of open research questions here, so maybe we could talk about that a little bit. As you described, there have been some very striking improvements in machine learning recently, but there's a lot that can't be done. I mean, if I go to my daughter's preschool, I would see young children learning and using language in ways that your software can't match right now. So can you give us a summary of the territory that's still to be explored?
Yeah, I mean, there's a lot still to be done. I think there's a couple of sort of areas which researchers around the world are furiously trying to attack. So one is learning from smaller numbers of examples. Today, the learning systems that we have, including deep neural networks, typically require really large numbers of examples, which is why Jeff was describing they can take a long time to train, and that the experiment time can be slow. So it's great that we can give systems hundreds of thousands or millions of labeled examples, but clearly small children don't need to do that. They can learn from very small numbers of examples. So that's an open problem. I think another very important problem in machine learning is what the researchers call transfer learning, which is learning something in one domain and then being able to apply it in another.
Right.
Right now, you have to build a system to learn one particular task, and then that's not transferable to another task. So, for example, the AlphaGo system that won the Go championship in Korea, that system can't a priori play chess or tic-tac-toe.
Right.
So that's a big open problem in machine learning that lots of people are interested in.
Okay. And Jeff, this is kind of on your group to some extent, isn't it? You need to figure this out. Are there particular avenues or recent results that you would highlight that seem to be promising?
Yeah, I mean, I think we're making actually pretty significant progress in doing a better job of language understanding. I think if you look at where computer vision was, 3 or 4 or 5 years ago, it was kind of just starting to show signs of life in terms of really making progress. And I think we're starting to see the same thing in language understanding kinds of models, translation, parsing, question answering kinds of things. In terms of open problems, I think unsupervised learning, being able to learn from observations of the world that are not labeled, and then occasionally getting a few labeled examples that tell you these are important things about the world to pay attention to, that's really kind of one of the key open challenges in machine learning.
Right.
And one more I would add is, right now, what you need a lot of machine learning expertise for is to kind of devise the right model structure for a particular kind of problem. For an image problem, I should use convolutional neural nets, or for language problems, I should use this particular kind of recurrent neural net. And I think, one of the things that would be really powerful and amazing is if the system itself could devise the right structure for the data it's observing. Right? So learning model structure concurrently with trying to solve some set of tasks, I think would be a really great open research problem.
Okay. So instead of you having to design the system and then setting it loose to learn, the learning system would build itself to some extent?
Right. Right now, you kind of define the scaffolding of the model, and then you fiddle with parameters as part of the learning process, but you don't sort of introduce new kinds of connections in the model structure itself.
Right. Okay. And unsupervised learning, I mean, just giving it that label, it makes it sound like one unitary problem, which may not be true, but will big progress on that come from one flash of insight and a new algorithm, or will it be, I don't know, a longer slog?
Yeah, if I knew, that would be okay. I have a feeling that it's not going to be like 100 different things. I feel like there's a few key insights that new kinds of learning algorithms could pick up on as to what aspects of the world that the model is observing are important. Mm-hmm. And knowing which things are important is kind of one of the key things about unsupervised learning.
Okay. Now, Aparna, so what Jeff's team kind of works out eventually should come through into your hands and you could build stuff with it. Is there something that you would really like him to invent tomorrow so you can start building stuff with it today, the day after?
Auto-generate emails. No, I'm kidding. I do think actually, so what's interesting is you've heard kind of these building blocks, right? So machine perception, so computer vision wasn't a thing, and now it's actually reliable. Language understanding, it's getting there. Translation is getting there. To me, the next other building block that if you can make machines do is hand-eye coordination. So you've seen the robot arms video that like Sundar showed at the keynote. But imagine if you could kind of have these rote tasks, that are hard or like tedious for humans. But if you had reliable hand-eye coordination that built in, and that's in a learned system versus a control system code that you usually write, and it's very brittle, suddenly it opens up a lot more opportunities, right? Just off the top of my head, why isn't there anything for like elderly care, right? Like you are an 80-year-old woman with a bad back, and you're picking up things. Why isn't there something there? Or even something as mundane with natural language understanding, right? I have a 7-year-old, I'm a mom of a 7-year-old. Like, why isn't there something for, I don't know, math homework with natural language understanding?
So I think one of the things we've learned in the last few years is that things that are hard for people to do, we can teach computers to do, and things that are easy for us to do are still the hard problems for computers.
Right. Okay. And do you think, does that mean we're still missing is there some big new field we need to invent? Because, I mean, most of the things we've been talking about so far have been built on top of this deep learning and neural network.
I mean, I think robotics work is interesting because it gives the computer system an embodiment in the world, right? And so learning from tactile environments is a new kind of learning, as opposed to just looking at unsupervised or supervised. Like just reading text is a particular environment. Yeah. Perception, looking at images, looking at audio, trying to understand what this song is. That's another kind of problem. I think interacting with the real world is a whole other kind of problem.
Right. Okay. That's interesting. Maybe this is a good time to talk a little bit more about DeepMind. I know that they are very interested in this idea of embodiment. The idea you have to submerge this learning agent in a world that it can learn from. Can you explain how they're approaching this?
Yeah, sure. I mean, DeepMind is another research group that we have at Google, and we work closely with them all the time. They are particularly interested in learning from simulations. So they've done a lot of work with video games and simulations of physical environments, and that's one of the research directions that they have. It's been very, very productive.
Okay. So is it just games? Are they moving into different types of simulation?
Well, there's a very fine line between a video game and a three-dimensional video game and a physics simulation of any environment, right? I mean, some video games are in fact full simulations of worlds. So there's not really a bright line there.
Okay. And do DeepMind work on robotics? They don't, I don't think.
They're doing work in a bunch of different fields, some of which is published, some of which is not.
Okay. And the robot arms that we saw in the keynote on Wednesday, are they within your group, Jeff?
Yes.
Okay. So can you tell us about that project?
Sure. So that was a collaboration between our group and the robotics teams in Google X. Actually, what happened was one of our researchers discovered that the robotics team actually had 20 unused arms sitting in a closet somewhere. They were a model that was going to be discontinued and not actually used. So we're like, hey, we should set these up in a room. And basically just the idea of having a sort of little bit larger scale robotics test environment than just one arm, which is what you typically have in a physical robotics lab, would make it possible to do a bit more exploratory research. And so one of the first things we did with that was just have the robots learn to pick up objects. And one of the nice properties that has, it's a completely supervised problem. The robot can try to grasp something, and if it closes its gripper all the way, it failed. And if it didn't close it all the way and it picked something up, it succeeded.
Right.
And so it's learning from raw camera pixel inputs directly to torque motor controls. And there's just a neural net there that's trained to pick things up based on the sort of the observations it's making of things as it approaches a particular object.
And is that quite a slow process? I mean, the fact you have multiple arms going at once made me think that maybe you were trying to maximize your throughput or something.
Right. So if you have 20 arms, you get 20 times as much experience. And if you think about how small kids learn to pick stuff up, it takes them maybe a year or something to go from like being able to move their arm to really being able to grasp simple objects. Right. And by parallelizing this across more arms, you can pool the experience of the robotic arms a bit.
I see. Okay. And
they need less sleep.
Right. John, at the start of the session, you referred to this concept of an AI winter, and you said you thought it was spring. When do we know that it's summer?
Summer follows spring. I mean, there's still a lot of unsolved problems. I think problems around dialogue and language are the ones that I'm particularly interested in. So until we can teach a computer to really read, I don't think we can declare that it's summer. I mean, if you can imagine computers really reading and internalizing a document. So it's interesting. So translation is reading a paragraph in one language and writing it in another language. In order to do that really, really well, you have to be able to paraphrase. You have to be able to reorder words and so on and so forth.
Right.
So imagine translating something from English to English, right? So you read a paragraph and you write a different paragraph, right? If we could do that, I think that I would declare summer.
Okay. Reading is, well, there are different levels of reading, aren't there? I mean, do you know,
If you can paraphrase, then you really
then you think
can
if you
say
can reach
that
that level,
actually understood
then you've got
the
somewhere.
document. And to a certain extent today, our translation systems, which are not perfect by any means, are getting better. They do some of that. They do some paraphrasing. They do some reordering. They do a remarkable amount of language understanding. So I'm hopeful that researchers around the world will get there. And it's very important to us that our natural language APIs become part of our cloud platform and that people can experiment with it and help.
Right.
One thing I would say is I don't think there's going to be this abrupt line between spring and summer, right? Like, there's going to be developments that push the state of the art forward in lots of different areas in kind of this smooth gradient of capabilities. And at some point, like, something becomes possible that didn't used to be possible, and people kind of move the goalposts of what they think of as like sort of really, truly hard problems.
Right. That's
the classic joke, right? Like if it's only AI until it starts working, and then it's computer science.
Like if you'd asked me 4 years ago, could a computer write a sentence given an image as input? I would have said, I don't think they can do that for a little while. And they can actually do that today. And that's kind of a good example of something that has made a lot of progress in the last few years. And now you sort of say, OK, that's in our tool chest of capabilities.
OK. But if we're not that great at predicting how the progress goes, does that mean we can't see winter if it comes back?
I mean, if we stop seeing progress,
then you'll know.
Then I think we could question what the future is going to look like. But today, the rate of I think researchers in the field are excited about this, and maybe the field is a little bit overhyped because of the rate of progress we're seeing. Right. Because something like speech recognition, which didn't work for my wife 5 years ago, now works flawlessly. Because image identification is now working better than human raters for many fields. There's these narrow fields for which algorithms are now superhuman in their capabilities. So we're seeing tremendous progress, and so it's very exciting for people working in this field.
Okay, great. I should just note that in a couple of minutes we will open up the floor for questions. There are microphones here and here in the main seating area, and there's one microphone up in the press area, which I can't see right now, but hopefully you can figure out where it is. Sundar Pichai, CEO of Google, has spoken a lot recently about how he thinks we're moving from a world which is mobile first to AI first. I'm interested to hear what you think that means. Maybe Aparna, you could speak to that.
I think it's, I interpret it a couple different ways. One is if you look at like how mobile's changed, how you experience computing, it's not happened at one level of the stack, right? It's at the interface level, it's at the information level and infrastructure. And I think that's the same thing that's going to happen with like AI and any of these machine learning techniques, which is you'll have infrastructure layer improvements. You saw the announcement about TPU. You'll have a bunch of like algorithms and models improvements at the intelligence and information layer, and there'll be interface changes, right? So the best UI is probably no UI.
Right. Okay. John, what does AI first mean to you?
I think it means that this sort of assistant kind of layer is available to you wherever you are, right? Whether you're in your car, or whether it's ambient in your house, or whether you're using your mobile device or laptop, that there is this smart assistance that you find very quietly useful to you all the time, right?
Okay.
Kind of like how Google search is for most people today. I think most people would not want search engines taken away from them, right?
Yeah.
So I think that being that useful to people so that people take it for granted and it's ambient across all your devices is what AI first means to me.
Okay. And we're in the early stages of this, you think?
Yeah.
Yeah. Okay.
Yeah, it's a journey, I think. It's a multi-year journey.
Okay, great. So thanks for a fascinating conversation. Now we'll let someone else ask the questions for a little bit. I will alternate between the press mic and the mics down here at the front. Please keep your questions short so we can get through more of them, and make sure they're questions, not statements. We will start with the press mic, wherever it is.
There's nobody there.
I really doubt the press has no questions. But is that what's happening? Why don't we start with the developer mic right here on the right?
I have a philosophical question about prejudice. People tend to have prejudice. Do you think this is a stepstone that we need to take in artificial intelligence? And how would society accept that?
I'm not sure I understand the question. Some people have prejudice, and
some people have like the tendency to have prejudice, which might lead to behaviors such as discrimination.
So the question is, will the systems that the people build have biases?
Oh, I see. Well, I see. Will people's prejudices creep into machine learned systems? I mean, I think that is a risk. I think it all depends on the training data that we choose. We've already seen some issues with this kind of problem. So I think it all depends on carefully selecting training data, particularly for supervised systems.
Yeah. Okay. Is the press mic working at this point?
Hello. Hi, I'm Sean Hollister. I'm up here in the press mic.
Great. Go for it.
Hi there.
There you are.
I wanted to ask about the role of privacy in machine learning. You need a lot of data to make these observations and to help people with machine learning. I give all my photos to Google Photos, and I wonder what happens to them afterwards, what allows Google to see what they are, and is that ever shared in any way with anyone else? Personally, I don't care very much about that. I'm not worried my photos are going to get out to other folks, but where do they go? What do you do with them? And to what degree are they protected?
I think this one. I think this is, one of the most important things that we look at across products, right? So even with photos or Google Now or voice and all of these things, there's actually two principles we codify into building this. One is there's a very explicit, it's a very transparent contract between the user and the products. That is, you basically know what benefits you're getting with the data, and the data is there to help you, right? That's one principle. But the second is, by default, it's an opt-in experience. You're in the driver's seat, right? In some sense, let's say, you're saying, hey, I do want to get traffic information when I'm on Shoreline, because it's like clogged up till Shoreline Amphitheater. You, of course, need the system to know where your location is, because you don't want to know how the traffic is in Napa. So having that contract be transparent, but also an opt-in, I think it really addresses the equation. But I think the other thing worth adding here is also that, by definition, all of these are for your eyes only, right? In terms of like all the data, your data is yours, and that's an axiom.
And to answer his question, we would never share his photos, right? We train models based on other photos that are not yours, and then the machine looks at your photos and it can label it, but we would never share your private photo.
To what degree is advertising anonymously targeted at folks like me based on the contents of things I upload, little inferences you make in the metadata? Is any of that going to advertisers in any way, even in aggregate, hey, this is a person who seems to like dogs?
For your photos, no, absolutely not.
No.
Okay, let's go to this mic right here.
My question is for Aparna about what is the thought process behind creating a new product, because there are so many things that these guys are creating. So how do you go from, because it's kind of obvious right now to see if you have my emails and you know that I'm traveling tomorrow to New York, it's kind of simple to do that on my calendar and create an event. I mean, how do you go from robotic arms trying to understand how to get things to an actual product? The question is, what is the thought process behind it?
Yeah, I'll give you the short version of it, and obviously there's a longer version of it. Wait for the Medium post. But I think the short version of it is, to echo one thing JG said, you want to pick problems that are easy for machines and hard for humans. So AI plus machine learning is not going to turn a non-problem into a real problem that people need solving. It's like, if you can take Christopher Nolan and like Ben Affleck, and you can still end up with Batman versus Superman, right? So you want to make sure that the problem you're solving is a real one. That's many of our failures, even internally and external, like frenzy around like bots and AI, is when you kid yourself that the problem needs solving. And the second quick insight there is that you also want to build an iterative model. That is, you want to kind of start small and say, hey, like travel needs some assistance. What are the top 5 things that people need help with? And see which of these things can scale.
I would add one thing to that, which is like often we're doing research on a particular kind of problem, and then when we have something that we think is useful, we'll sort of share that internally as presentations or whatever, and maybe highlight a few places where we think this kind of technology could be used. And that's sort of a good way to inform the product designers about what kinds of things are now possible that didn't used to be possible.
OK, let's have another question from the press section up there.
Yeah, there's a lot of talk lately about sort of a fear of AI. Elon Musk likened it to summoning the demon. Whether that's overblown or not, whether it's perception versus reality, there seems to be a lot of sort of mistrust or fear of going too far in this direction. How much stock do you put into that? And how do you sort of win the trust of public when you sort of show experiments like the robot arm thing on the keynote, which was really cool, but sort of simultaneously creepy at the same time?
So I get this question a lot. I think there's this notion that's been in the press for the last couple of years about so-called superintelligence, that somehow AI will beget more AI and then it'll be exponential. I think researchers in the field don't put much stock in that. I don't think we think it's a real concern yet. In fact, I think we're a long way away from it being a concern. There are some researchers who actually think about these ethical problems and think about AI safety, and we think that's really important, and we work on this stuff with them, and we support that kind of work. But I think it's a concern that is decades and decades away. It's also conflated with the fact that people look at things like robots learning to pick things up, and that's somehow inherently scary to people. I think it's our job when we bring products to market to do it in a thoughtful way that people find genuinely useful. So a good example I would give you is in Google products, when you're looking for a place, like a coffee shop or something, we'll show you when it's busy, right? And that's the product of fairly advanced machine learning that takes aggregate signals in a privacy-preserving way and says, yeah, this coffee shop is really busy on a Saturday morning. That doesn't seem scary to me, right? That doesn't seem anything like a bad thing to bring into the world. So I think there's a bit of a disconnect between the somewhat extended hype and the actual use of this technology in everyday products.
OK, next question.
So given Google's source of revenue and the high use of ad blockers, is there any possibility of using machine learning to maybe ensure that the appropriate ads are served? Or if there's multiple versions of the same ad, that the ad that would apply most to me would be served to me and to a different user, a different version, and things like that? Is that on the roadmap?
Yeah, I mean, I think in general, there's a lot of potential applications of machine learning to advertising. Google has actually been using machine learning in our advertising system for more than a decade. And I think one of the things about sort of deciding what ads to show to users is you want them to be relevant and useful to that user, and it's better to not show an ad at all if you don't have something that seems plausibly relevant. And that's always been Google's advertising philosophy. And other websites on the web don't necessarily quite have the same balance in that respect. But I do think there's plenty of opportunity to continue to improve advertising systems and make them better and better so that you see less ads, but they're actually more useful.
Thanks.
OK. Next question from up the top.
Jack Clark with Bloomberg News. So how do you differentiate to the user between like a sponsored advert and one that is provided by your AI naturally? How do I know that the burger joint you're suggesting is like a paid-for link or is a genuine link?
So in our user interfaces, we always clearly delimit advertisements. And in general, all ads that we show are selected algorithmically by our systems. They're not like you can just give us an ad and we will always show it to someone. We always decide what is the likelihood that this ad is going to be useful to someone before we decide to show that advertiser's ad.
And does this extend to stuff like Google Home, where it'll say, visit a sponsored restaurant we're going to send you to?
I don't know that product.
Well, we
I
haven't
it's-
launched Google Home yet.
Yeah,
So a lot of these product decisions are still to be made. I think we do, as a general rule, clearly identify when something is sponsored versus when it's organic.
Okay. Next question here.
Hi, this is a question for Jeff Dean. I'm very much intrigued by the Google Brain project that you're doing. Very cool T-shirt.
Thank you.
The question is, what is the roadmap of that, and how does it relate to the point of singularity?
So, I mean, the roadmap of this is sort of the project code name for the team that I work on. Basically, the team was developed to investigate sort of the use of sort of advanced methods in machine learning to solve difficult problems in AI. And we're continuing to work on pushing the state of the art in that area. And I think that means working in lots of different areas, building the right kinds of hardware with TPUs, building the right systems infrastructure with things like TensorFlow, solving the right research problems that are sort of not connected to products, and then figuring out ways in which machine learning can be used to advance different kinds of fields as we solve different problems along the road. So I'm not a big believer in the singularity. I think all exponentials look like exponentials at the beginning, but then they run out of stuff.
Okay. Thanks for the question. Back to the press box.
Yeah, hi. Stephen Max Patterson, IDG. I was looking at Google Home and Google Assistant, and it looks like it's really a platform, and it's a composite of other platforms like the Knowledge Graph, Google Cloud Speech, Google Machine Learning, the Awareness API. Is this a feature that other consumer device manufacturers could include, and is that the intent and direction of Google, is to make this a platform?
It's definitely the case that most of our machine learning APIs are migrating to the cloud platform, which enables people to use, for example, our speech capabilities in other products. I think the Google Assistant is intended to be actually a holistic product delivered from Google that makes sense, but it may make sense to syndicate that to other manufacturers at some point. We don't have any plans to do that today. But in general, we're trying to be as open as we can with the component pieces that you just mentioned and make them available as cloud APIs, and in many cases as open source solutions as well.
Right, I think one of the things about that is making those individual pieces available enables everyone in the world to take advantage of some of the machine learning research we've done and be able to do things like label images or do speech recognition really well. And then they can go off and build really cool, amazing things that aren't necessarily the kinds of things we're working on, but sort of.
Yeah, and many companies are doing this today. They're using our Translate APIs. They're using our cloud speech APIs today.
Right. We have time for one last quick question from this mic here.
Hi, I'm Jaroslav from OEB. John, you said that you would declare summer if, in language understanding, if it would be able to translate from one paragraph in English to another paragraph in English. Don't you think that making that possible requires really complete understanding of the world and everything that's going on, just to catch the emotional level that is in the paragraph, or even the physical understanding of the world around us?
Yeah, I do. I think that's I use that example because it is really, really hard, right? So I don't think we're going to be done for many, many years. I think that there's a lot of work to do. We built the Google Knowledge Graph in part to answer that question, so that we actually had some semantic understanding of at least the things in the world and some of the relationships between them. But yeah, it's a very hard problem, and I use that example because it's pretty clear we won't be done for a long time.
Okay. That's it. Sorry, there's no time for further questions. Thanks for the question. A good forward-looking note to end on. We'll see how it works out over the coming years. Thank you for joining me, all of you on stage, and thanks for the questions and coming for the session.
Cool.